Hello and Assalamualaikum. My name is Ahmad Nazran bin Yusri. I'm from group NasCo, and today we are going to present about our assignment 2, which is about the Robocar. So my group members is me, Ahmad Nazran bin Yusri, Muhammad Hafizul bin Abdul Manab, Muhammad Faiz Aiman bin Fakrul Razi, and lastly Muhammad Amruddin bin Zulkifli. So first, let's look at the table of content for this presentation. We will start with introduction, the objectives, what is concurrent programming, activity timeline, code breakdown, lab activities, and lastly the tournament day. So the introduction. The Robocar competition challenges participants to program a line following robot using both RTOS and non-RTOS methods. So this presentation, we will discuss the development of the Robocar and highlight the significance of concurrent programming in this project.
Hi, now we move to our objective. The first one is to apply real-time and concurrent knowledge in programming. The second one is to program a line following robot using RTOS to ensure that it will navigate through the track that consists of four different checkpoints, which is checkpoint A, B, C, and D. And lastly is to understand the relationship between timing variables and the Robocar's performance. Okay, now we move to the concurrent programming. What is this concurrent programming? So, concurrent programming is a programming technique that allows multiple process or thread to run simultaneously rather than sequentially. This means that different parts of program can be executed at the same time. Hence, it will improve the performance and the responsiveness of the program. In this context of line following robot, the concurrent programming could be used to handle multiple tasks at once, such as reading data sensor, controlling motor speed, and adjusting the robot's direction. So, by using this concurrent programming, this task can be managed efficiently without waiting for one to complete before starting another, leading to smoother and more effective operation of the robot.
Okay, next, let's talk about what we did during our real-time programming project with the Robocar. We planned several events, and here's a rundown of how things went. First up, on June 1st, we had our initial lab. We kicked things off by setting up AVR Studio and doing some basic programming. This helped us getting familiar with the code and understand how the Robocar moved. By the end of this lab, we had a pretty good grasp of how the line sensors work, which was super important for our next step. Then on 8 June, we had our second lab. In this session, we focused on making the Robocar's movement smoother, especially when it came to sharp turns. We also spent time testing the obstacle sensor and the light sensor to figure out what adjustment we need to make in our programming. This was a crucial part of making sure our Robocar could handle different challenges. Moving on, we had a quiz on 21st June. This quiz was for all of students and included the question related to everything we had been doing in the labs. It was a good way to test our knowledge and make sure we were all on the same page. On June 22nd, we had our final lab session. This was all about testing and refining our Robocar programming. We adjusted the values detected by the light sensor and also tuned the Robocar movement when it encountered the obstacle. It was a lot of work, but it really paid off in improving our Robocar's performance. Finally, on June 23rd, we took part in the Robocar tournament. This was the big event where we got to test our Robocar against others and see how well it performed in a competitive setting. It was a lot of fun and a great way to wrap our project. So that's the timeline throughout the Robocar project. So next, in our programming setup, we have integrated several key sensors to enhance our Robocar's functionality. Firstly, the line sensor serves as a crucial navigation tool, which is used to detect and interpret the position of lines on the ground. This information guides the Robocar's movement, allowing it to follow designated paths accurately. Secondly, the light sensor measures the ambient light intensity. When this intensity exceeds a predefined threshold, the Robocar responds by moving forward briefly before executing a precise right turn. Lastly, the obstacle sensor plays a crucial role in ensuring the Robocar's safety and navigation. Upon detecting an obstacle, it prompts the Robocar to halt its movement, execute a right turn to maneuver around the obstacle, and then resume the intended path. We also utilizing the sensor to detect any Robocar from other team and to stop our Robocar for a few seconds to avoid collision. These sensors collectively empower our Robocar to navigate and react to different environments and to operate safely according to the rules during the competition.
So next we move to the next part, which is to identify the three different detection in the Robocar. So firstly is the line detection. So in this programming, we put here the switch case where we have 7 case here. So the first case is when it is the sensor detects the right, which is the right sensor. So in this case, if it is on right, then the Robocar is set to turn right. And the next is the case of the center, which is 010. So for this case, if the middle sensor is detected, then we program it to go straight. The next one is the left, which is 100. So the left sensor is detected. So in this case, we program it to turn left if the left sensor is detected. And then next we have the middle and also the right sensor, both detected. So for this case, we program it to for the Robocar to go for sharp turn right. And next one is the left and center, which is the middle and also the left sensor is detected. In this case, we also program the Robocar to go for sharp turn left. And then next we have the all of the sensor are detected, which is 111. If this case is executed, then we program the Robocar to go straight only. And lastly, if none are detected, which is on default, which is on 000, so we program the Robocar to go for the reverse. So that is all for the line detection. Next is the light detection. So in this code, we put here the value of threshold we mentioned here is the 80. So in this case, if the light detected and the value of the light detection is more than 80, then the program is executed. So in this case, when the value of 80 is exceeded, then we program the Robocar to go straight for 0.6 seconds, and after that we go for the sharp turn right for 0.5 second, as we can see from the time delay we set here on 500 millisecond. And lastly, after it has go sharp turn right, the triggered light sensor is set to 1 to ensure that this case is only happen once, and after that the Robocar will continue move as usual in normal operation. And lastly, we have the obstacle detection. So in this code, we put here the obstacle and also the flag parameter. So in this case, the flag is the value is at 0. So if an obstacle is first detected, we program here that the Robocar is stopped for 0.5 second. And next, we program the Robocar to turn right for 0.38 second. And then after turn right, they will have to move straight for 1.2 second. So when go for the straight, the Robocar will eventually find the line again, so they can continue the normal operation. And that is for the first case. And then after that, as we can see here, we set the parameter flag on +1. So now the value of flag is on 1. So basically after that, if the flag parameter is greater than 0, so it means that the Robocar face another obstacle, which in the competition, the Robocar might be face the other car. So if another obstacle is detected, we program it to stop for 0.5 seconds before it can continue move as normal operation. So that is all for the three detection: the obstacle, the light detection, and also the line detection. So that is all from me.
So now let's look at the lab activities video. So in this video, it will show some of the activities that we've been doing during the lab session, such as programming, testing, and also adjusting the timing constraint of the Robocar. So let's enjoy the video. Basically, what we did is that the robot follow the line and also to make the corners lah. We're just testing the navigation of the robot and the capability of the robot. So we are facing some difficulties here, but in the end we managed to pass it. And now we are testing the roundabout section. Now let's look at the video during the tournament day. So here the race just started, and right off the bat we face our first issues on making the right corner here. So we have to restart again. And now we managed to pass it, but then we face some difficulties here. So we have to restart again. And now we already passed all that junction and also the light sensor obstacle. And now the robot is trying to make this T junction here. The robot's supposed to make a right turn here, but it didn't manage to make that. So until the end of the race, the robot stuck there indefinitely, even though we have already programmed the code when facing the obstacle after that, and also we programmed the code during the roundabout, but we cannot show that since our robot stuck here. So as a conclusion, this Robocar game is very interesting and fascinating. First, because it teaches us a lot of newfound knowledge, such as the real time programming, concurrent programming, and much more. And second, it exposes us to programming on a hands on object, on a physical object, because we usually program for a website or maybe mobile application or system. So, this is a new thing for us. Um, this game provides us the opportunity to experience um, programming on a physical object. And lastly, because of this event, we managed to create bond between our team and managed to create uh, successful teamwork. So that's all for this presentation. Thank you very much for spending your time and have a nice day.